All right, good morning, everyone. I am taping. This is Jeff Scott. Welcome to day 5, Monday, May 22nd. This is the online AWD1100 C# programming class. Today, I want to make a couple, I don't know if you'd say announcements, but I want to talk a little bit about the first test we took. Then I'm going to jump right into chapter 4 and do both chapter 4 and chapter 5 today, if we have time, and we'll see how it goes. Tomorrow, then I'm going to go over chapter 6. And I notice already there that should say event, not even, but that's okay. So Wednesday, we'll have a pretest on chapters 4, 5, and 6. And Thursday, we'll have our second hands-on test. Let's talk for just a second about the first hands-on test. Some people, for whatever reason, some people appeared to be a little bit confused. All right. So let me just say there were 3 problems on the test. You were supposed to do this first problem here, which was the T-shirt console app. All right, so a T-shirt console app. Then you were supposed to replicate it by doing a GUI T-shirt app. And then finally, you were supposed to go in and do this GUI-based converter app. So the first test was those 3 problems. Now, with that said, your homework that you were given this week was to do problems 2-1. This was due yesterday. The test was due Thursday by midnight. All right. But the homework was extra 2-1, where you designed this form, and then extra 3-1, where you put the code in. All right. If you're ever confused as to exactly what I'm asking you to do, please, by all means, ask, and ask right away. All right. Now, for this week, you'll notice if we go back up to the top here, you will have problems for chapter 4, problems for chapter 5, and problems for chapter 6. 1, 2, 3, 4, 5, 6, 7 problems. All right. We're going to do some of those as a class, not all of them like we did before, but at least a couple of them, at least probably half. If there's 7, we may do 3. I don't know. All right. Now, also for the first time, we may look at see what's in here. This section 2 projects. And again, let's not talk about that right now. Let's get into that more later on in the week. Okay. All right. So with that said, then today, the goal is we have now gone over chapter 1, how to get started with Visual Studio. Chapter 2, how to design a Windows Forms app. And chapter 3, how to code and test a Windows Forms app. So in other words, we are now totally finished with section 1 of the book. Now, even though it's a little bit off from what it says in the syllabus, I'm hoping we can do chapters 4, 5, and 6, all of those this week. Then next week, all right, do 7 and 8, and the following week, 9, 10, and 11. Now, a couple things. First of all, your homework was due yesterday for chapters 1, 2, and 3. All right, so were the written test. Your homework, labs, and written tests for chapters 4, 5, and 6 will be due this Sunday, the 28th. All right. Also, 1 week from today, May 29th, there will be no class. There will be no class because a week from today is Memorial Day. So we'll have off for Memorial Day, which will kind of skew the way we've been doing things. All right. So next week, there won't, probably at least, there will not be a hands-on test. It'll be pushed off into the following week. We'll talk about all that as we get on a little bit. But let's today go over chapter 4, how to work with numeric and string data, and chapter 5, how to code control structures. So I'm going to jump right into chapter 4. And as it says, this chapter shows you how to work with various data types. All right. It says in particular, you'll learn how to perform arithmetic operations, how to work with string data, and how to convert from one type to another. All right. So as typically most of the chapters in here, and actually most of the chapters are broken down into 3 or 4 sections. This one has 5. How to work with built-in value types, how to work with strings, how to convert data types, 4 other skills for working with data, and then we'll look at an enhanced version of that invoice total map. All right, so like I said, let's get to it here. So these are your built-in C# data types. All right, and if I counted 4, 5, 6, 7, 8, 9, 10, 11, looks like there's about 13 of them, something like that. Now, I will tell you, with most programmers, I'm not saying every programmer there is, but with most programmers, you won't use byte, all right? Even though that there are times that probably would make a lot of sense to use. I don't think I've ever used sbyte in a program. So what I'm telling you is the ones that are in here, in this whole group in here, you'd probably use int most of the time. If for some reason you needed a number bigger than 2,147,483,647, you might use a long. All right. And I can't even read that number to you because I don't know what it is. All right. So what I'm saying is in this group, in these 1, 2, 3, 4, 5, 6, 7 that you see right here, probably 99% plus of the time, the only ones you will use are int and long. All right. I've never used an unsigned long. I've never had a reason to. The thing with when you use a float and a double are almost the same thing. All right. Because both a float and a double allow you to put in numbers that have decimal places in them. You'll notice that a float it says 7 significant digits, whereas a double is double that, or 14 significant digits. If you make a variable a float, you must put an F at the end, just like you put an M at the end for decimal. All right. I occasionally still use doubles. I'm finding myself more and more as time goes on that I'm not using these. I'm not using these. I'm very rarely using these, but I'm using decimal a lot. Again, notice a non-integer number with up to 28 significant digits. All right. And then finally in here, yeah, I use bools all the time. That's the true false, and occasionally a char as well. All right. Why would you use a char? Well, if you wanted a single character, maybe somebody's middle initial or something like that. I don't know. So what I'm saying is out of these 13, the ones you'll probably work with the most will be int, long, decimal, char, and bool. All right, those 5 out of the 13. If you need a little bit more explanation, you can take a look at what's here. All right, we've gone over much of this material that's in here, but again, when you look at this example, that conveniently enough says example above it, they are taking and declaring a variable of type integer on one line, then assigning it a value on another line. That works well if you don't know in advance what the value of your variable will be. But if you do, it doesn't make a lot of sense to put this in if it's going to be one line after the other. If you already know, then you typically will do it like the example here. Int counter equal 1. All right. You'll notice when we go down a little further, you can even put multiple ones on the same line if they're separated by commas. I don't do that. I don't see the what that really buys you. I know that other people, sometimes people tell me, "Oh, you put in more code than you have to." But I would always put those in as int x equals 0 semicolon. Then on the next line, int y equals 0 semicolon. Maybe that's just me. All right, but that's just the way that I do it. So you know already that a variable is basically it's an area in memory that contains a value that may change or vary as the program executes. Doesn't mean it will change, but it can change. Before you use a variable, you have to declare its type. It says and assign an initial value to it that may or may not be true. Remember, if all you put in here is this int counter, by default, C# basically will take that and it will initialize it to 0. If you have any doubt, you can always initialize it yourself. All right. So as it says, common initial values are 0 for integers, 0.0 for decimal or for double, false for Boolean. All right. Again, for float, you must put a upper or lowercase f. For decimal, you must put an upper or lowercase m. All right. Now, under these naming conventions, what the author is trying to do here is kind of give you some best procedure type of guidelines. So as it says, start the name of a variable with a lowercase letter. So if you have a variable like tax rate, and you're going to run those two words together, make it a lowercase tax, then an uppercase r, and a lowercase ate. As mentioned there, that's known as camel case notation. Finally, it says try to use meaningful names that are easy to remember as you code. What you're going to see when we get into the next chapter is there are a couple of occasions where it's okay to break that rule about meaningful names. But usually, what you're doing when you give your variables meaningful names is you are making your program more self-documenting. All right. And one thing I've always found, most programmers don't write as many comments as they should. I will tell you that when I was a professional programmer, I cannot tell you the number of times that I had to go and dig through code just to find out that most of the variables were named something like I, J, K, M, N, etc. And they're used all over the place, and you have to track them down to see exactly what they mean. All right, that's just not a smart idea to do. All right, constants. Now, this was on the test. All right, I'm going to disagree with the book here. All right, so in the book, I just want to show you this. In the book, it says this: const int days in November equal 30. And then after that, it says const decimal sales tax equals point, I would have put a 0 there, but 0.075 M. Now, to show you how I would do these, I would have said here const int days in November equal 30 and const decimal sales tax equals 0.075 M. Now, am I going to take off? You know what? I when I was grading these, and I did grade the tests. Unfortunately, some people had problems knowing exactly what to do or turning in everything. So you will get them back, hopefully by tomorrow. Okay. All right. But many people either did it the way they showed here in the book, or you made your constants lowercase. Now, I might have even shown it like that on the test. I don't remember, so let's quickly look. So let's see. There, it's all in uppercase, so that's good. And no, I did all mine in uppercase. And I wish you would do the same. Now, I people always say, well, what if I don't? Are you going to take off? I probably could have taken off a lot more on this test for different things than I did. But it just, when what this does here and here is it basically sends out a sign, a signal, whatever it is you want to call it, that says that's a constant. Don't ever put that after we've declared it and initialized it here. Don't again put it on the left hand side of an equal sign. All right. So I wish that you'd make your constants all uppercase. And again, they mentioned use names that make sense. Okay. All right. So most of the operations that you see here, let's just say, put it this way, the top half that you see here should all make sense to you. Plus sign for addition, minus sign for subtraction, an asterisk for multiplication, and a forward slash, don't use a backslash, a forward slash for division. Now the modulus we've looked at already, that's the remainder operator. All right. You can preface any variable, like when they've got down here x equal 14. You can say int x equal plus 14. I've never seen it like that, but you can do that. And of course, you can preface something with a negative sign. So these two are the other ones. And you're going to find out as we go on and on that you're going to use those probably more and more. So let's look at a realistic example here. All right. So let's say that we came in here and we said int x equal 23, int y equals 17. All right, I'm literally just made these up. So now if I say int sum equals x plus y, well, you should all know this, that it is 23 plus 17 or 40, right? If I say int diff equals x minus y, well, that's the same thing as 23 minus 17 or 6. If I say int prod for product equals x times y, well, that's what? 23 times 17. I just did the math in my head, and if I did it right, all right, I think it's 391. All right. And if I do an int diff, I'm sorry, an int quote equals 23 divided by 17. Remember, this is kind of special. Since I'm dividing an integer by an integer, it throws away the decimal portion and it gives me 1. All right. And then finally here, if I do the mod, all right, that's the same thing as saying 27 mod 3, or mod 17 rather, or it says, give me the remainder. Well, it goes in there one time and there's a remainder of 6. So all those probably make sense to people. There's no biggie, no surprise or anything right there. Now, when you do these, you can put a plus sign before either or both. Again, you very rarely, if ever, see that. If they are negative, you can put a minus sign before them. All right, so none of those are new. So that should handle everything 1, 2, 3, 4, 5, 6, 7. So let's look at these last two. All right. If I do this, if I say I'm making a brand new variable here, I'm going to say int z equal 12. Okay. Then I'm going to put in 3 dots here, which means there's some code in here. I don't know what it does. I don't care what it does. But somewhere later on in my program, I say either plus plus Z or I say Z plus plus. That's the same thing as saying Z equals Z plus 1 or Z plus equal 1. Those all. So all this one and this one and this one and this one, they all add 1 to Z. So which one should you use? Well, that's the most typing, and that's considered the worst way of doing it. Whether you use the plus plus right here or the at the beginning or the end, right? In this example, it doesn't matter. I'm going to show you an example in a minute where it is going to matter. All right. But I would suggest using either this one or this one. Now, the plus plus, and it has an equivalent. So the plus plus adds 1. There's also a minus minus that removes 1. Those only work if you want to either add 1 to a variable or subtract 1 from a variable. If you wanted to add 10, you can't say like Z plus plus 10 or 10 plus plus Z. Then you have to either do it like this or even better, like that. All right. So that's all fine and dandy. Let's have another variable in here. I'm going to just create, I'm going to say int y, and I'm not going to give it a value. All right. And I'm going to take all of this that I put in here and just comment out the whole line. So that whole line, just pretend for a second, at least the whole line is commented out. So we're going to put it here, or this, or that. All right, let me even move this down. So right now, y has no value because I said int y. So it has a value. I guess it does. It has a value of 0. All right. Now there is a difference between this and this. There is a difference between those. This is called increment and assign, and this is called assign and then increment. What do I even mean by that? Well, imagine only one of these was here. So even though I've got them both listed here, for now, imagine I was only going to use, use one of them. This is a shortcut for saying this, to say Z equals Z plus 1, then Y equals Z. Why am I showing you this? Because what this line does is it increments Z first. So Z is now 13. Then it takes 13 and it assigns it to Y. All right. So in other words, Y and Z both equal 13 when you're done with this. All right. And like I said, I'm just hoping that that makes sense to people. Now let's pretend we didn't have this one here and we did this one. All right. Now what's going to happen is this is going to change. Now what we want to do is we want to say, immediately take Y, take Z and assign it to Y. So in other words, meaning Y is now equal to 12. Then add 1 to Z, meaning Z equal 13. So look at the difference between those. In this case, we increment and then assign, so they're both the same value. In this case, we assign, then we increment. So this actually has a value that's 1 less than this. And I always tell people when you're learning this stuff, if that doesn't make sense, don't use it. Do it as 2 different lines of code or do it in whatever way makes the most sense to you. All right. And again, if I grab this and make this a minus minus and make this a minus minus, now it's the same thing as z equals z minus 1 or z minus equal 1. Then y and z are both equal to 12. All right. In this case, all right, y equals z, meaning that, in fact, these are both 11. I'm sorry. Okay. In this case, y equals z, meaning y equal 12, then subtract 1 from z. All right, meaning that in this case, z is going to be equal to 10. All right. Again, if that confuses you, move that over so you can see it. If that confuses you using something like this, then don't use it. Write it as two different lines. You should be programming right now for understandability on your part. I've said this several times before. All right. Now, I'm going to leave those. I'm just going to remove these here. All right. We've got this x equal 23 here. Let's just play with that one for a while. All right. In fact, let's add a z. We're not going to give it a value. Okay. Now, you know what? We won't need a z. I wanted to just show you one more thing. It's going to be probably on the next page of the book, but you might as well see it now. If I wanted to go and let's just say I wanted to add 10 to x, I could say x equal x plus 10, right? That'll work fine. But it's less typing to say x plus equal 10. These two statements are equivalent. They will do the same thing. All right. Not only is there that one, we've got an x equal x minus 10, which is, as you'd probably guess, x minus equal 10. All right. And we've got, let me just move them down or else I'll run out of room. We've got an x equal x times 10, which the shortcut is x times equal 10. We've got a divide. All right. And let me just show you the other one, which is the modulo. So these are called, typically the way that they're referred to that I've always seen is they're shortcut operators. All right. So instead of using this, you can use this. Instead of using this, you can use this. And I could highlight the other three, but you get the idea, hopefully. Again, if that confuses you, don't use them. I want you to understand what it is you're attempting to do at any time. All right. That's more important to me than you learning and having to use some kind of a shortcut. And that's really what these are, is they're shortcuts. All right, let me jump back into here. I will tell you that these operators here, all of these are binary operators, which means there has to be something on the left and something on the right. All four of these are known as unary operators, so there doesn't have to be something on both sides. All right, here's those assignment statements then. Now, I just tried to show you some examples. You already know that the equal sign is assignment. And they have, if you like their examples better than mine, then use that. All right, it says besides the equal sign on the bottom here of page 101, C# provides the 5 other shortcut operators that are shown there. All right, the next thing that's discussed here then is the order of precedence. Hold on a moment, I think somebody's joining. Good morning. I'm into, well, try it again. All right. All right, good morning. I'm in here and I'm into, let me double check, see, make sure there's nobody else that's waiting here. Okay, it looks like you're both in. All right, I'm going over chapter 4. Let me tell you real quickly what I've done so far before we went into chapter 4, and that is um, people had problems with a few things on the test. Let me quickly mention what they had problems with. Some people, for whatever reason, didn't seem to understand what I was asking you to do. You know, when you took the test, the idea was you were going to do these 3 problems. There was one problem here that had this t-shirt application that was a console. There was another problem that had the t-shirt application as a GUI. And there was another problem where you did the inches to centimeters conversion. That was the test. All right. On the other hand, you were also given these extra exercises where you were supposed to do 2-1, where you designed this form, and then 3-1, where you generated the code for the form. Now, you might say, well, yeah, of course, but some people had a little bit of problem understanding exactly what I was asking you to do on the test and exactly what your homework was. If that ever happens, please immediately send me an email if you have any questions on what is due, when it's due, or whatever that happens to be. All right. Or if you're in class like this, open up your mic and just ask. That's totally fine. All right. Okay. Now, the reason I'm telling you that is out of the people in the class, there were a couple people that either didn't complete the test because they didn't understand what was being asked for, or, you know, for whatever reason, I just didn't have a test turned in. I am still waiting right now on one person to turn in part of the test and another person to turn in the entire test. Once that happens, and I'm hoping that happens today, I've asked for the stuff today, then tomorrow morning I will send out your grades. It'll have a piece of paper, the test page, and it'll show you if I took off on for anything, I'll show you why I took off and what your final grade was for the test. In addition, by tomorrow, all right, I will also have your first homework and written tests graded. So what should happen tomorrow is when you come in and you look at your grade at Inside Rankin, you should know after 1 week and a day or two exactly where you stand. All right. So we did that first, and then I jumped right into chapter 4, and that's where we are right now. So I'm about 10 pages in. So far we've been talking a little bit about some arithmetic operations. I went through these. So we talked about the basic operations, and most people get this without a problem. All right. In other words, um, the plus, the minus, the multiply, the divide. And I don't know why I used the numbers there instead of the variables, but I did. And exactly what that would give you. Then we looked at the plus plus and the minus minus. So again, when you say this, if I say x plus plus, or if I say plus plus x, all right, that's the same thing as if you said x equal x plus 1, or if you said x plus equal 1. All right. The plus plus, and there's an equivalent one in here with a minus minus. They only work if you want to, if you want to either add, come on, if you want to either add one or subtract one. So you can't say x plus plus 10 or 10 plus plus x or x minus minus 10 or 10 minus minus x. They only work with one. All right. There's another thing that you can do with this too. So if you do this, if I come in here and say this, z equals plus plus x, and z equals x plus plus, these actually give you different answers. This one here says add 1 to x, and x was 23, so x will now be 24, and then assign that value to z. So z would be equal to 24. This one says take the value of x, which is 23, assign it to y, and then add 1 to x. So in this case, both x and z would be 24. And in this case, all right, z would be 23 and x would be 24. And as I mentioned earlier in class, if using these operators, which are designed to be pretty much shortcut operators, if they confuse you, do not use them. All right. If this, especially if this is your first class, I want you to understand conceptually what's going on and not get where you're hung up in, oh, do I have to use this shortcut? Do I have to use this shortcut? All right. I want, you should be programming for understandability on your part. All right. And finally, we went in and we said that if we have this, x equal x plus 10, that's a shortcut for it. If we have x equal x minus 10, that's a shortcut for it. If we have x equal x times 10, that's a shortcut for it. X equal x divided by 10, that's a shortcut for it. And x equal x modulo 10, that's a shortcut for it. So that's what you've missed so far, okay? And now we're up to order of precedence for arithmetic operators. One way you can always change this order of precedence is to use parentheses. If you have any doubt over what's going to happen first, use parentheses, and that'll remove all doubts. If you don't use parens, you do any plus plus or minus minus things, you do those first. Then you use if you've got a plus sign before a number or a minus sign before a number, then you do multiplication, division, and modulo. You go from left to right. Finally, at the end, you do addition and subtraction. All right, and they give you some examples here. But to be honest with you, they're not great examples. So let's quickly take a look at our own example in here. So we've got this x, y, all right, and let's just add a couple more variables in here. So let me come up here and do this. So I'm going to say here int a equal 12. I'm making all this up as I'm saying it to you. Int b equal 10, int c equals 14, and int d equal 27. All right, if I do something like this, so let's make one more variable. We'll call it int e. All right. Now, if I say something like e equal a plus b divided by c times d minus, I don't know, let's just put c in here again. All right. That actually is a valid thing to do. But the way that this works is the first thing it's going to do is it's going to say, oh, I've got a plus, I've got a divide, I've got a multiply, and I've got a minus sign. So the order in which it's going to do these is first, it's going to do b divided by c, because you do division, all right, before you do addition. So that'll happen first. Second, it'll take the result of this and it'll multiply it by D. So it's going to take the result and it's going to divide it by D. All right. Third, it's going to say A plus the result of number 2. All right. So it'll be A plus this. All right. And then finally, or lastly, it'll say the result of number 3 minus C. Now you can override and totally change that. So let's say I wanted to do this first and I wanted to do that second. Then all I'd have to do would be to come in here and do parentheses here and here, and do parentheses here and here. All right. Now, if I do that, then what happens? I do A plus B first. Then second, I do D minus C. All right. Then third, I do the result of number 1. And I divide that by C. And finally, all right, I take the result of what? Well, it's going to do, let's see, that result. All right. So the result of number 3, and I'm going to multiply that by the result of number 2. So you can always change around the order of things happening by using parentheses. If you're in doubt, use parens. All right. Now, this would be fine. If I was going to do this, I would also add a set here and here. You don't have to do that. All right. But to me, it makes more sense to do that. All right. That just, I'm trying to eliminate any confusion that the computer might have. Also, I want to make sure that the computer is going to be doing this in the order I want it to be done. All right. The next thing that's discussed in here is casting. We've talked about this a little bit, but I want to show you an example in here. So again, I'm going to come down here and put some more stuff down here a little bit. So do this. All right. So I'm going to come in here and I'm going to say this. Int x equals 17. Int y equals 9. And now I want to say decimal z. And I want that to be equal to x divided by y. You might know this already. You might not. I don't know. So it's going to take 17 and it's going to divide it by 9. All right. And what's the answer to that? I don't know. It's something like 1.88888. It's something like that. But don't worry. It has nothing to do with this word decimal. This has to do with the fact that I'm dividing a whole number by a whole number. So C#, like most programming languages, throws away that. And that's what it gives you as an answer, is just 1. So how do I keep that? There's 3 ways that I can keep this. All right. And what I'm about to show you right now are what are called explicit casts. If something is done explicitly, explicitly, that means I do it. If something is implicitly done, I am implicity. The computer or the language or whatever does it for me. I have to do it here. So I can either say decimal right here, or I can say decimal right there, or as it's shown right now, I can do both. That will give me that answer. All right. Now, because people get confused here, but realize this is called casting. I am taking a copy of what's in X. I'm not changing X, How do I know that? It's on the right-hand side of an equal sign. All right. Since it's on the right-hand side of an equal sign, I'm changing a copy. All right. So that's totally legit to do that. Again, I can cast one, I can cast the other, or I can cast them both. But those are what are known as explicit casts. What they start talking about in the book are implicit casts. Who cares about that? Let me show you another example. All right. Let's look at these right here. And I'm going to copy them down, but I'm going to make a couple changes. All right. So I'm going to make this one a decimal. And I'm just going to put here 9M. All right. Now, if I do this and I say here x divided by y, I am going to get this. What happens is it says, okay, you've got a decimal here and you've got an int here. Okay. So basically look at it as an apples and oranges type of thing. Here, we made both of them. We made both of them an orange, let's say. Here we've got an apple divided by an orange, but it says, oh, since one of these is a decimal, what it does implicitly is it basically comes in and it does this. You don't see it, but this is what it does so that it can make sure that it is dividing an apple by an apple, an orange by an orange, or whatever. That is an implicit cast because it is being done for us by the software. So when they talk in the book here about something being done implicitly, all right, it's just something built into the language. If something is done explicitly, you have to do it. And they pretty much explain that in here as well. All right. All right. The next thing that's discussed in here, it's 8:47. I'm going to go till 9 o'clock and then I'm going to take a 10-minute break. All right. I know that some of you join late and that's okay, but that's typically that's the way I like to run things. So the math class is the first time we're going to see something in here that's a little bit different, even though it may or may not look like it. What do I mean? The math class is known as a static class. Now, we don't talk about classes until chapter 12. But normally, if you create your own class, and again, you don't have to worry about what it even means, but if you create your own class, you have to create what's called an instance of the class in order to be able to use it. Since the math class is static, static means you don't have to create an instance. You can just start using it. And there's some pretty powerful things here. There's a round function, which will round something up or down. There's a pow function, which does exponentiation. There's an sqrt function, all right, which allows you to use square roots. And there is a min and a max, which typically take two or more values, and it'll give you, it's usually two values like they show here, the biggest for math.max or the smallest for math.min. All right. And they show you some examples in here as well. I think at least it'll make a little bit more sense when we look at these things to actually look at them in the guise of a problem. But if we do look here, notice what we have. 23.75, we tell it to round it to one decimal place. So it rounds up because it's 0.7, point something 5 or above. So we get 23.8. All right. Now notice here, and I don't know if this is even right. I don't think that it personally that it is. It's 23.85 with a 1. I think that's going to be 23.9. I think that's a mistake in the book. All right. Here is 23.744 with 2. And you can see that. This one, again, I'm not sure if that's right or wrong. How do you know? You write a simple program and you put those in. All right. Here's a math.pow. So this is saying 5 squared. All right. If I put a 5 there and a 3, that's 5 cubed type of an idea. Here's the square root of 20.25. Here's the biggest of those two numbers. Here's the smallest of those two numbers. All right. These are known as static methods. Math is the name of the class. Again, don't worry about that so much right now, but you may have to use these in some of your assignments. All right. So when you say math dot, the IntelliSense is going to kick in. And it'll, as far as some of the things that allow you to do, there will be things like round, pow, SQRT, max, min, etc. All right. And those are all explained right here. I mean, some people will say they're kind of like the calculator functions. All right. You could look at it that way, I guess. All right. Going along with that is working with random numbers. Now, when you work with random numbers, you've got to do a couple things that for right now, again, until we get to chapter 12, may seem a little weird. All right. You're going to have to do something like this. Random number equals new random. Let me just mention in this example that's here, the word number that you see right there, you could call it almost anything. If you wanted to call it rand, R-A-N-D, you could call it that. All right. If you wanted to call it R, which would be a bad name, but you could do that. But we are creating a random number right there. That's not creating the random number. What that is doing is it's creating an instance of the random number class. If that makes no sense to you, please don't let it bother you. It's just that this is an example of something that you have to do in order to work with random numbers. All right. So after you do this, if you were to type number dot next, you get a number between 0 and what was it? 217 billion, 480, 483 million, six, whatever that number was that we saw at the beginning. A big honking number. All right. By default, with most programming languages, not this, but with most programming languages, when you create a random number, all right, it's going to look a little different, so I'm going to just put it up here. But when you create a random number in most programming languages, you get a decimal number that's greater than or equal to 0 and is less than 1. So you might get a number like 0.4567190, something like that. All right. The biggest number you could get would be 0.9999, as many nines as you can. You can't get 1 and you can get 0. All right. Well, you'll notice again, it's a little bit different because here we're working with whole numbers. So you get a number greater than or equal to 0, but less than the biggest value you can have for a 32-bit integer, whatever that is. All right. Now, if you put a different number in here, then you get a number that's greater than or equal to 0 and less than whatever number you put in there. So if I was going to randomly generate grades, and grades could be between a 0 for somebody failed and 100 where somebody got it perfectly, all I would change in there, in fact, I'd leave it just like it was. It'd give me a number greater than or equal to 0 and less than 101. All right. If I said that it had to be between 1 and 100, then you'd use the next one down. And notice there is a double that works as well. That's the way it works in most programming languages. So if you want random whole numbers, you just use next. If you want random numbers that have a decimal in them, you use next double. All right. And they show you a simple example in there as well. This would be basically you simulating rolling 2 die. So this would give you a number between 1 and 6, and so would this. All right. And they go into it in a little bit more depth and breadth of coverage here, and they talk about seed values, etc. Again, my goal here is not to confuse you. So I'm not going to go over and read all that stuff and go through it. I told you what I think, at least for now, you need to know. All right. All right. So let's jump in and talk a little bit about strings. We have talked about strings a little bit before, but let's talk about them some more. All right. So let me again do this. Now, some of you in this class last semester were in the AWD 1000 class. All right, it's a class where we talked about a lot of stuff. One of the things was JavaScript. In JavaScript, you could do something like this. You could say, let first name equal Jeff. You could also say, let first name equal Jeff. In other words, you could use either single quotes or double quotes. You cannot do that in C sharp. If you try, the second one will give you an error. All right. Well, we use string. You have to do it like that. If I try doing this, I'm going to get an error because in C sharp, when you use single quotes, it expects what the type is going to be a char, an individual character. So I could come in here and do something like this and say the middle initial is P. That would be okay. But when you work with strings, they have to be put in there in double quotes, even if it's empty. So this is known as the empty string. Even if I just put the character, right there, even if it's just one character. If I am going to work with just one character, I can use a char. All right. So they come in here and they explain how you can set a string to nothing. And there's a bunch of different ways you can do that. You can say string.empty, not a problem. All right. So in the example I just gave you, all right, we could do that. Now, I don't know about you, but if you give me my choice here and say that I can sit there, and I guess you don't put the parens there. That's how often I use that. If you give me the choice of those two and you say you can use either one, I'm going to use the first one all the time. Why? Because it's less typing. But if you want to use the second one, you can. It's not a problem at all using it. All right. The other thing that you can do is, and they show that here as well, whoops, is you can type in this. All right. Null will be somewhat important in this class. It'll be more important later on in the class, and probably even more important than that in future classes. Null technically means unknown. All right. If your name is Betty and you walk into, let's just assume for a second that we have an actual classroom class, not an online class like this, but a classroom class. And you walk into class the first day and you say, "Hi, are you the teacher?" And I say, "Yeah," I introduce myself. And then you introduce yourself. And even though it would be none of my business to ask a question like this. But if I said, "Well, what's your grade point average?" Again, I would never do that, but let's just pretend I did. And Betty comes back and says, "Well, this is my first class. I haven't taken any other classes here." Well, then technically your grade point average is null. You don't have one. Some people sometimes mistakenly think that null means zero. It doesn't. It means unknown, because there's a big difference between saying you don't have a grade point average and your grade point average is 0.0. All right. So any of these three would work as far as initializing a string to nothing. All right. And that's what they mention in here. All right. We will talk about this null forgiving operator and some of this other stuff a little bit later on in the chapter here. All right. Earlier, we talked about using that plus equal. You may or may not remember that up here. we talked about using the plus equal, and we said that this and this are the same thing. You can use the plus equal with strings as well to concatenate or join together two different strings. Totally legit to do that. All right. Do you have to do it that way? No, there's more ways of doing it than that. But if you look up on the screen here, I'll tell you what, let's go until 9:15. So we'll finish this part of the chapter. All right. So they show you the three ways to initialize a string. Then they show you how you can join a string or two strings. And you'll notice they put a blank space in there. If they didn't do that, then it would be Bob Smith and it would be run together and there wouldn't be a blank space right there. Okay. You can join together a string and a number. You can do that. What it does is it will do what's, again, an implicit cast, and it'll make this a string. Now, I want to show you their example again. This is the example that's right here. I'm going to rewrite it. All right, so they have here decimal price equal 14.95 M. And then they have string price string equal price plus price. And that's totally fine. All right, it'll actually do this, probably what you want. If I was writing it, I like to mix apples and apples. So I would change this and put in here, even though it's more work, a two string, and I would put in here a C for currency. Because by doing this, I no longer need the dollar sign. That'll put it in for me. I think that doing it that way, even though it's a little bit more typing, is much cleaner than doing it the way they show it. All right. The bottom line is going to be this. When you do a test or when you do a homework or when you do a lab, all right, did your program work? Did it provide the correct results? Right? Okay. You can use, like I said, the plus equal in there. That's totally fine. So a string, the big thing about a string has no numeric value. So if I come through there and I do something like, if we had said here, instead of decimal price equals this, had we come in there and said something like this, string price equal 14.95. I don't know why you'd want to do that, but if you did, this is not $14.95, or this is not 14 and 95 hundredths. This is the string 14.95. This has an arithmetic value of 0. All right. The reason that that becomes important will be later, much later in the semester, when we talk about things like databases. And if you want to store information in a machine, for instance, if I asked you your telephone number and your number was, in fact, I'll put, my number in here. This is my office number here. So if I said string phone equal 314-286-3675. That is my office phone. You can call it whenever you want. I'm very rarely there, but you could. On the other hand, if I did this, okay, that still is it, but both of those have no numeric value to them. This is not what 1, 2, 3, 1, 2, 3. This is not 3,142,863,675. This is just a character string with no numeric value whatsoever. All right. And pretty much everything that's in here, I just went over with you. Now, it does say that sometimes, all right, when you want to set something to null, like we said earlier, so come on. So if you want to use null, all right, they don't show it in the example here. Oh yeah, they do. But notice after the word null, they put an exclamation point. All right. That's called the null forgiving operator. If you don't put that in, sometimes it won't matter. Sometimes you'll get a warning from the system that says, hey, it's a string, it shouldn't be given a value of null. But by putting that exclamation point at the end, what you're saying is, hey, I know it's a string, just don't worry about it. It's got a value of null, but don't worry about it. Special characters in strings, just so you know, these are called escape sequences right there. I will tell you that probably well more than 95% of the time, the ones you're going to be the most concerned with are going to be the first two. The first one in there, a \n, is like you hitting the enter key. So if you want to put something on a new line, that's one way of doing it. The \t, it's like you hit your tab key. Now, later on in the semester, later on, you're going to notice that there's going to be a time or two then that you might want to use a combination of \r and \n. I don't want to get into it right now. Later on in the semester, there's going to be two ways that you're going to be able to refer to a file. One way to do it is by using \\, like they show right there. Again, I don't want to get into that right now. And if you wanted to basically say something is used as a quotation, you could use the last one. So they give you examples here. But again, the ones that you should be the most concerned with are the first two. \n for new line, \t for tab. All right. And yeah, they actually do give you this example using the verbatim string literal. I don't want to get into that right now, but later, I think it's chapter 17, we'll talk about files, and then you'll learn about the importance of using that @ sign right there. I would never, when the book goes and gives you, just kind of some odd little thing that they're like, we'll talk about this later. All right, in the book, I'm not going to sit there and pull something like that out and give that to you on a test. You may get a question about something like that on one of your written test problems, but on an actual test, I'd never do anything like that. That would be silly to do that. Now, there's something new. I hadn't seen this before the new book. This is called a raw string literal. And if you look at the example here on the top of page 115, it's different. What do I mean? You'll notice it starts with 3 double quotes and it ends with 3 double quotes. And everything that you put inside of it goes in there verbatim. In other words, it goes in exactly the way you typed it. So, in this example right here, they're showing, something from a poem or something like that. All right. If you wanted to do that, you could. I have never used this. I had never seen the usage of a raw string literal before I got to this book. But there might be a time, all right, such as what they show right here, that it would be a very nice thing to have. Okay. All right. Let's see. Well, we can look at a little bit at converting data types. All right. Some of this stuff that's in here, some of it you've seen that we're about to go over. Some of it that we're about to go over, you have not seen. That's not a warning. I just want you to know that. All right. So you'll notice it says common .NET structures that define value types. All they're trying to show you in here is by default, what are the size of these different things. So really is byte with a little byte is part of the byte with a big B class. Short is part of the int16, etc. Do you need to worry about that? The answer is no. All right. These are the ones you're going to use in your code. These are the ones you're actually in the background referencing. These are the ones you're going to use, and these are the ones that you're referencing. All right. If that confuses you, just pretend we didn't even have that page. All right. Now, they do mention in here that a structure defines a value type and a class defines a reference type. This is one thing that probably at first isn't going to make a lot of sense, but you're going to have to understand the difference between a value and a reference. All right, let me quickly tell you the difference between them. When you work with a value type, you work with a copy of something. When you work with a reference type, it's not a copy, it's the real thing. Now, I'm going to show you an example of that later. So don't worry if that didn't make any sense to you right now. All right. You will get a copy of it, or we will look at a copy of it in just a little bit. Now, the reason that this stuff is important, and we've started to look at this already, we're going to do this section, then we're going to take a break. And that is, we've done a little bit of work with the toString already. All right. And we've done a little bit of work with parse or convert. All right. But we haven't really looked at try-parse yet. This is getting us into what we're going to be talking more about next week when we get into chapter 7. All right. ToString basically says, I want to take whatever I put in those parentheses and treat it as though it's a string. Whether it's a number or whatever, I want it to be a string. In other words, typically you use ToString when you're printing out the result of something. And at that time, you're not doing a calculation, so you don't need to worry about an arithmetic value. All right. Parse means that basically I want to do something. I want to convert something. So if I parse something, if I parse it, notice it's a string, but if I parse it, I could turn it in from a string to a decimal or a double or an int32, etc. Any of those that are shown in this second table. The difference between a parse and a try-parse is you do a parse if you, in your own mind at least, if you have 100% certainty that what you're about to do will work without any problem. It's going to work. If you're not sure, you don't use a parse, you use a try-parse. And you'll notice with the try-parse, it says on there, result. Result is a Boolean. Remember, Boolean is true, false. That if you tried to do the parse, if you tried to convert that string to something else and it worked, result will be true. If you tried to take that string and convert it to something else and it failed, result will be false. All right. After we get done, pretty much once we get into this chapter, we're going to start validating our input. Okay. And what do I mean by that? On that first test that you took, if you put a number in there, if it said, how many t-shirts do you want to buy? And if you put a number in there that, it would work. Even if you put a negative number in there, it would work. But if you left it blank or you put a non-numeric value in there, it wouldn't work. We're going to fix that by, instead of using like a convert or a parse, we're going to use a try-parse. And then we're only going to go on if that result was true. And if that result was false, we'll give the user an error message and we won't allow the program to go on. So you're going to see examples of this. We're going to do a program where we're going to do something like this and you're going to see it in action. There's nothing wrong with the examples that are here. They're just fine. But I think until we put that into context and you can actually see that inside of a program, I think then it will make a lot more sense. All right. And finally, before we take our break, how to use methods to convert numbers to formatted strings. We've looked a little bit at this. I mentioned this one to you earlier. If you do a dot to string and inside of the parens, you put double quote C double quote, upper or lowercase, it makes a currency. P will make a percent. N will make it a number. These are the three that I use virtually 100% of the time. I don't think I've ever used a float or a digits or an exponential or a general. I don't think I've ever used those. I just use C and P and N. And there are some examples in here on how those can be used. So we're going to start not just, we're also going to start prettying things up, so to speak. All right. So it is 9:15. Let's take 10 minutes. I'm going to refresh my water. So I'll be back in just a couple minutes and we'll pick it up here on 4 other skills for working with data. See you at 9:25. Be right back. All right, it is 9:25, so I'm going to continue on. Just so you know, we've got about 12 or 13 pages left in this chapter. When we get done with this chapter, I'm going to go back again, if you remember, into that payroll example that we did day one. And we're going to make a copy of it. We're going to make some modifications to it so we can add in some of the material that we discussed in this chapter. After we get done with that, we're going to go into chapter 5 and talk about the stuff in chapter 5. And when we get done with chapter 5, we're again going to come back to this program and make some changes to it. So as we're doing this, if something doesn't make sense, please feel free to stop me at any time. All right. The first thing they're going to talk about in this section about 4 other skills is they're going to talk about what's referred to as scope. And scope has to do with 2 things. It has to do with who can see what and how long something stays around. Now, if that confuses you, let's take a quick look at the example that they have on the next page. All right. These 2 variables that are right here, one called number of invoices and one called total of invoices, they're both defined outside of any routine that's in here. In other words, they're not in this, they're not in this, they're not in this. Since they're defined outside of any routine that's in the program, they have what is known as class scope. What that means is anything in this particular program can use them. There's one copy, and I should just say the original, whatever you want to say, and it's shared by everybody. So if I happen to change number of invoices in here, it's changed when I get down here as well, or vice versa, or I could change it in both. All right. On the other hand, when you create variables in here, so these variables were created inside of the calculate. All right. Once this routine goes away, so do the variables. But these variables live as long as the program lives. And again, if that doesn't totally make sense to you, all right, then just bear with me because we're going to be looking at some examples of it. All right. So as it says here, the scope of a variable determines what code has access to it. And what that means is, since these are local variables right here, this subtotal, discount percent, etc. If I try to refer to those variables inside of here, I'm going to get an error because they're not known inside of there. All right. As it says, the scope is determined by where you declare it. If you declare it within a method, it's got what's known as method scope. It's what's known as being more of a local variable. If you declare it within the class, but not in any method, it's got class scope. Technically, it's a global variable then. All right. A variable with method scope can only be referred to by statements within that method. A variable with class scope can basically be referred by anything. And then there's that lifetime that I mentioned. The variable with method scope only is available or only lives while the method executes. The variable with class scope, all right, lives as long as the program lives. All right. I don't know why the author showed you this here, but they did, so we're going to talk about it. And enumeration, it's also called an enum or an enum, all right? Basically, it's where you can declare your own class. And you might say, wait a minute, that's kind of weird. Why would I ever want to do that? Well, let's look at the example that they show here. All right. So this is a brand new type of variable. The type of variable, the name of the variable it's a terms variable. It is terms. All right. It has 3 values in it. So if you declare something of type terms, it can only be a net 30 days, a net 60 days, or a net 90 days. All right. technically right now, in this example that's right here that I'm circling, net 30 days has a value of 0, net 60 days has a value of 1, and net 90 days has a value of 2. Why does it have those values? Because since I didn't give them any, it defaults to 0 for the first one, 1 for the second one, and 2 for the third one. All right. Here, they've changed it. So net 30 days equal 30, net 60 days equals 60, all right, etc. So why would you even want to use something like this? All right. Actually, the example here is not a bad example because with many companies, net 30 days means that payment is due 30 days after the product has been shipped out. Net 60 days means that the payment is due 60 days after the product has been shipped out, and net 90 days, you get the picture. All right. What you're putting into that enum, they're constants. They're called members of the enumeration. Now, I've seen examples where people have used this and they want to create their own variable type. And like right here, they would say enum days of the week short. And it would say like Sunday equals 1, Monday equals 2, Tuesday equal 3, and go all the way down to Saturday equals 7. If you wanted to do that, you could. The idea behind using an enumeration is you can create your own data type, which has its own possible values that you set up, and those values like they put in here, you give them values, or you can give them values. Now, with that said, I would never have introduced this right here. I would have waited till later in the book, because right now with what we've been doing, there really isn't a lot of use for this. All right. There's nothing wrong with it. I just wouldn't have introduced it here myself. All right. The next thing that's in here, this is probably going to be the most confusing thing that we've done in the book so far. All right. And that is talking about working with null value types and the null coalescing operators. All right. Again, null means unknown. Notice what it says. By default, if you declare a variable to hold an int or a decimal, or really any kind of numeric type or a bool, it can't store null. All right. In other words, if you declare a variable to be of type bool, it has to be true or false. It can't be unknown. If you declare a number, it can be 0 or positive or negative, but it can't be unknown. By default, that's the way that it's set up. But as they mention here, C# has a feature that's known as nullable types, which does allow you to do that. So when you do that, as it says, you type a question mark immediately after the type of the value, like this. Int question mark quantity. So what that means is it is legal for quantity to hold a value of null. All right. And notice if you want to be able to set, so that's an int, but here we've got a decimal called sales total, and we have to have it, that can hold a value of null. Here we've got something terms from that enum that we just created, that can have a value of null. Now, the reason that this is important, not so much in this class, but when you take your last class in the program, AWD1100, database-driven website development 2, and you really are working intensely with databases, you will use stuff like this a lot if you want to allow null or unknown values. And with what we're doing right now, I'm not going to say that it's not important, but it's not nearly as important. All right. Then there's another one in here that's called the null coalescing operator. Now, I'm not going to lie to you either. I've had problems using this one. I've had this give me errors and I don't know why. All right. But what this means is, okay, if if the value of QTY, if this is null, then with the two question marks, that means assign -1 to QTY. If it's any other value other than -1, so any negative value or 0 or whatever, as long as there's a number, you're going to set number to it. Now, typically you would set this up, since it's a quantity, it would be 0 or positive. So you might make extra checks in here. But what they're saying is if the quantity has not been set it to -1. All right. That's the null coalescing operator that you can use to assign a default value. Then they've got another one with an assignment operator. It's doing kind of the same thing with a double question mark. It's basically saying that if sales total doesn't have a value, we're going to make sure it does by assigning 0.0m to it. You can end up getting some really ugly statements with nulls. But again, the good news for us is it becomes much more important when you're working with databases. And by that time, you'll have used this kind of stuff a lot more when you're actually going to really need to use it. All right. All right. As it says, there is nullable reference types. Now, we talked about this before, and I'm gonna put something on the screen here just so you see it. All right. Value and reference. All right. I've used this kind of example, or maybe I think I have at least before, but I'm going to show you something. I'm going to say this int. This is what we're going to be getting to in later chapters. So if it doesn't make sense, just listen to me and try to see if you can work your way through it. I'm going to say int x equals 145. Int y equals 73. All right. Now I'm going to say int sum equal add 2. Don't worry, I'm going to go over all of it in just a minute. X and y. All right. Then I've got some code in here. I don't know what it is, but there is some code in here. All right. Now I'm going to come down and I'm going to type in this private int add 2 int n1 int n2 return n1 plus n2. All right, like I said, I expect this to make very little sense to you, so let me walk you through it. All right, when I call this right here, when I make this call, what the system does is it makes a copy of X and it makes a copy of Y. So really, when I do this, it's going to call a routine and it's going to pass in this. All right. So in other words, this gets converted into this. It's making a copy of what's in X and a copy of what's in Y, and that's what it's going to do. Now, what this is, and you haven't seen this before, I get it, is I'm calling another routine that's called add to. Okay? When I call that routine, X will now be referred to as N1, Y will now be referred to as N2. And I'm telling the system to add those two, to add 145 and 73, which gives me 218. That 218 gets returned and stuffed right into there. Now, that may have made no sense to you, but we're going to keep working with this payroll program and write it to death, so to speak. And you're going to see examples of all of this stuff. All right. Okay. So why did I even tell you that? I mean, what does this have to do with anything? Well, in here, when they talk about nullable reference types, all right, these are all advanced topics. All right. So when you are using this, sometimes when you use certain things, you're either going to get errors because the system does not understand what you're talking about, or you are going to get warnings. And what the warnings are is the system, for lack of better words, is kind of trying to protect you from yourself. And what I mean is the system is saying, hey, this could end up being bad in the future if you do this. A warning does not stop a program from running. All right. Maybe I've told you about this, maybe I haven't, but I'll make it short and sweet. When I was back in the days when I was a professional programmer, one of the first things my boss had me do was to take this section of code that had some errors in it, and he wanted me to get rid of the errors. There were about 10 errors. It was a few hundred lines of code. And it gave me a good chance to really learn the language I was going to use, all right, etc. So I got those errors out. And took me a couple days. A couple of them were harder than others, but I went in and talked to my boss and I said, I've got these finished, but I have a question for you. And he said, what's that? I said, well, I've got the errors fixed, so the program runs. The problem is, and this is not a joke, I said, there's about 100 warnings in there. Do you want me to fix those as well? And he said, not no, but hell no. Because he's like, does the program run? Yes. Does it run with correct? Does it give correct answers? Yes. Then we don't care. Well, by having, if you run your program and you have hundreds of warnings, first of all, it doesn't look like you know what you're talking about. And second of all, it is not impossible, depending on how the code is written, for a warning one day to become an error message in the future. So what they're telling you here is if you want to do this, you can go, as it says in the Solution Explorer, you can right click on the name of the project. Let's do this just so you see it. All right, so let me bring this down. So in the Solution Explorer, right click on the name of the project, on the project name. So we'll do our payroll GUI here. All right, and choose properties. All right. Then it says click on the build category right there. All right. It says from the nullable drop-down list, select enable. I don't even know where this is. From the nullable drop-down list. I don't even see one in here. So let's see. Well, these are my drop-downs here and here and here. I don't know. It might be off in advance someplace. I don't know. But what they're telling you is if you want to use this, so you can see it's a fairly uh, high level. It's not something you'd be doing typically in a beginning class. All right. But they're showing you that you can do it here. And what that will do is it will take situations in where you would typically get warnings and it will suppress those warnings. The warnings are still there. They just don't show. Okay. All right. And the last thing that's done in here is this basic invoice total app. They do it and then they redo it. All right. What do I mean? Let's look at it. We've done this one already. We've already done this. All right. Where you enter a subtotal, you've got a defined percent. You multiply the subtotal by the percent. That gives you your discount amount. You take your subtotal and you subtract your discount amount from it, and that gives you the total. We've done this before. All right. And I'm going to find it in just a minute. But now what they're saying is they want to enhance it. So how does it change? Well, notice what we have here. This is exactly the same as what we had before. But now every time we create a new invoice, we're adding one to our total number of invoices. All right. Every time we figure out a total, we're adding that to our total. And then we're taking all of our totals combined and dividing them by the number of invoices that we have here. So let's see if we can do that. All right. So I'm going to come in here, think I've got that invoice total saved in here, but come on, let me find it. There is invoice total right there. Copy that over here. I think I have this already out as, let's see, is there a Git in here? Yes. So it should already be out there as a GitHub repository. I will update the repo by the end of the class period today. Same thing with the payroll one. All right. There's my Git, and I will update that one as well. All right. So we've got this invoice total that right now, when we run it, let's see. We've got invoice total GUI 1 and 2. So 2 is the latest one we had. So let's look at that and let's run it. So let's make that the startup project and run it, see what it looks like. Okay, so we have this subtotal, discount percent, etc. So if I come in here and type 300 and click calculate, everything is in there. I clear. Okay, it all clears. I think this one will just set as a 15 and we'll leave it in there and we won't clear that. But what we want to do is add in here. We want to have the total number of invoices, the total invoice amount, and the average invoice amount. So I've shown you this before. What I'm showing you is not exactly recommended practice, but what I'm going to do is this. I'm going to go to here and I'm going to keep that up on the screen, but I'm going to come in and create a new project. All right. This will be a Windows Forms project. .NET Framework C# right here. We've got right now invoice total GUI 01 and 02. So I'm going to make this invoice total GUI 03. All right. And there it is. Now I'm going to jump back to where I just was. And I'm going to copy all that. And I'm going to paste it right into here. So now I've got a starting point. All right. And I'm going to unlock my controls. Why? Because I want to add some stuff here. I'm going to copy these 3 things. And I'm going to paste them right over here. All right, let me move this over a little bit. And we'll move this over a little bit. If you don't have any idea right now, if you're like, what the heck are you doing? What I want to do is I want to make this right here. All right, looks like these have to go down to here. All right, so what do we have? It looks like I might have to add more too. So I'll change all the labels and everything. Don't worry about it. We'll do all that in just a bit. Let's move these, get them down here someplace. And what else do we have in the book here? 1, 2, 3, 4, 5. All right, so we've got enter subtotal. Okay, and then there's the subtotal. So we want to move this down. All right, so let's fix this now so it looks like what it looks like in the book. All right. All right. I'm just going to play with my colors a little bit so this is a little easier for us to view. Oh, did the wrong one. That was on me. Okay, come on. That's what I wanted. Okay, so now what I want to do is I want to basically come in here and do what was shown in the book, which is this. All right. I'm not worried about the code right now. I'm worried right now about my interface. So I'm going to make a copy of this. Again, this is my enhanced version of the invoice total form. So this is what I want to build. All right, right here. And this right now is what I have. Okay, so I'm going to take this, I'm going to pull that down here. Now, every time I go and click up here, this is going to disappear, but I got subtotal, I've got discount percent, I've got discount amount, and I have total. All right, so I need to have enter subtotal up here. So this has got to be enter subtotal. All right, and this, if you look in here, it's kind of hard to tell, but everything that's in here other than enter subtotal, everything in here, these are all read-only. And we got calculate, clear, and exit. We've already got calculate, clear, and exit, so that's good. So this right here, this one and this one, I want to make read-only fields. So I highlighted them both. I'm going over to read-only, and I'm going to double click so read-only is set to true. This should say enter subtotal. So it'll be LBL enter subtotal, and this is going to actually say enter subtotal. Okay, so we've got all that done. This is already called subtotal, discount percent, discount amount, and total. So those are done. This has got to be TXT enter subtotal. All right. This is TXT subtotal, TXT discount percent, TXT discount amount, TXT total. Well, that's good. So it's getting there. This is BTN calculate, BTN clear, and BTN exit. All right, so the only ones I have to change are these three. And again, all I'm trying to do is make that look like this: number of invoices, total of invoices, and average of invoices. So this first one should say number of invoices. So this will become LBL number of invoices. And the text will be number of invoices. All right. And then the next one is total of invoices. Since that's LBL number of invoices, might as well grab all that and change this to TXT number of invoices. All right, so this will be total of invoices, LBL total of invoices. And the text will be total of invoices. All right, and we'll make sure that the name of the text box will be TXT total of invoices. Right, and the last one is average of invoices. And that should say of, not O. There we go. And finally, this one should be TXT average of invoices. All right, I'm going to come in here and just Click this down arrow to make sure everything has been renamed. I did not rename the form, so I will do that right now. So on my form, I'm going to right mouse click on it, choose rename, and make it FRM invoice total 2. Yes, I want to change the name, so that's all changed now. All right. It's not exact, but I think it's close enough that hopefully you can all see that that looks pretty much like this does. All right. So when we think about it now, the other thing that they did, I can do this, I don't have to, but they took these buttons and they brought them up like over here. Okay, we'll just do that. All right. I mean, I can make this smaller now if I want. You get the idea. I can play with it all I want. Let's lock our interface into place. All right. Somebody asked me, I got an email, why do you always lock your interface into place? Well, if it's in place like that, you can't move anything. So I can't click on this and accidentally move it one place or the other. Do you have to do that? Of course not. All right. I'm going to also set the subtotal, I'm sorry, the discount percent so that it is always 25. All right. So this will always be 25. How am I going to do that? Well, let me come into my code over here. And you'll notice the code did not copy over. All right. All of my stuff that I did copy over, but not the code. Okay. So the first thing I'm going to do is up at the top here, I'm going to create a constant. Const. It's going to be a decimal. And I'm going to call it discount percent. And I'm going to set it equal to 0.25 M. That is 25%. All right. Plus, I want to make sure that as soon as the program starts running, so in my load event, I'm going to say txt discount percent equals, all right, that discount percent, but I want it .toString and I want it to be a percentage. So you can see I'm already using some of the stuff. That's got to be .text. That's why I'm getting an error. All right. So now when I run this, oh, it's still running the old one. Let me put the new one up here. So now when I run this, it should be the orange one. Notice it's 25%. Now, one thing I want to do is when I click clear, I don't want that to clear out. And right now, well, it isn't because I guess because I didn't put that stuff in there yet. All right. Okay. So once we enter a number here, we want that number to go here. And then we want to multiply it by 25% or 1/4. That amount will go there. Then we'll take our subtotal, subtract from it our discount amount, and that will go there. Plus, we want to do a plus on the number of invoices. We want to add that total to our total of invoices. And whatever our total is in here, we want to divide it by the number of invoices that are in here. And then that number should appear here. Now, hopefully I didn't say that too fast, or at least it made a little sense. All right. So let's do a couple things first. I'm not going to do it exactly the way they did it in the book, but we'll do it, at least it'll be very similar. First thing I'm going to do is I'm going to grab that code that we've been using for our exit button. All right. And I'm going to bring that in. So there's our calculate button. There's our clear button. And there's our exit button. There's the code for the exit button. So that should now work. So let's just see if it does. Exit, no. Exit, yes. Okay, so that's working. All right, next, when we hit our clear, what do we want to clear? Well, we want there to be nothing in here or in here. We do want that 25% to stay in here. We want the discount amount to clear, and we want the total to clear. We don't want to clear any of these because these are running totals. All right, so we want to clear, 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 and clear. All right, so that's what we want to do in our clear routine. So TXT, first of all, what did we call this thing? I think TXT enter subtotal. Yep. So TXT enter subtotal dot text. And again, I can either say null or I can say string dot empty, but I just like to use that. All right. And we've got our subtotal. And what else was there? We want our discount amount and our total. Finally, we want to go back to this enter subtotal and we want to give that the focus. Let's see if that now works. Now, the only one we can put something in is this, all right? But I'm going to pretend there's something in there and in there and in there. And when I click clear, it cleared and there's my focus. That's all working. That's good. That's a great start. All right. Now, the next thing to do, of course, is in my calculate button. And before I do that, because a couple of you lost points on the test, all right, I'm going to come up here. I'm going to click on the form. I'm going to go to my accept button up here. If you didn't do this, you lost points. And for the accept button, I'm going to set it to BTN calculate. And then down for the cancel button, I'm going to set that to BTN clear. And I'm going to set my Windows start position to be center screen. Now, when I run it, it looks a lot nicer, at least in my opinion, there. All right. Plus, I'm going to make sure that I've got the tab order set. Now, when I set the tab order, this will be 0. I really can't do anything with these read-onlys, but I'm going to make mine 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. It's a little overkill, but I'm going to do it like that anyway. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And again, do a view tab order, and it's not a bad time to come in here and do a save all. All right. Now let's take a look and see how they coded it in the book. So they're going to start by making these 3 class variables. So this number of invoices, which is there, is going to be a class variable. This total of invoices, which is going to go there, is going to be a class variable. And this average of invoices, which goes there, is going to be a class variable. You'll notice that the number of invoices is an integer because that's a whole number, and the other 2 are decimals. So let me grab those. Just type them in manually. All right, and since those are class variables, the best place to put them then is right up at the top, right after this initialize component. So right there, there they are. So I'm going to declare and initialize my class variables. Those variables, again, are available anywhere in the program. They don't have to be passed in any place. They're grayed out right now because I'm not using any of them. We will in just a moment. All right. So in our calculate, this is what we want to do. And under these clear totals, this is what we want to do. All right, so I'm going to do it. Mine will probably look a little bit different than theirs, but the ideas will be the same. So let's look first in this calculate routine. And I'll take as much of this as I can. Now we're not done, but I'm up to, oops, I've got these 7 or 8 lines to go, and I've done these 6 or 7 lines so far. So let me grab those. And let me put those into here. So again, they will go into the calculate. All right, and I didn't spell very well, did I? All right, and I think I've got all my errors are out of there. That's good. Let's run it right now. I won't have those final totals, but let's see if it's working. 300, 300, 25%, 75, 225. Clear, okay. 100. Okay, it looks like it's working, at least right now. Now, I don't need to put in that 25 in there anymore. Like I did, I hard coded it in. I don't have to because the program did it in a different way, which is totally fine. So I don't need this. I'm just going to comment that out. All right. And let's put in the rest of the code, and then we want to discuss it. So we've got these 4 lines and these 4 lines. We have to put in these 8 lines. We've got 8 lines in, and we've got 8 more to put in. Leave those here. Just hit enter a few times so you don't see them anymore, and I'll put these in down here. All right. This is all of the code in the book. And actually, although I'm not berating the authors at all, what I'm going to do in a moment is I'm going to go in and I'm going to add or modify something that they did because I think I'll make it work better. All right, so do we have a TXT AVG of invoices? Should be there. TXT, I used average of invoices. Let's just change it to theirs. So I'll have AVG of invoices. Which means that this one will change too. All right, let's see if that fixed the error that I had. And it did. All right, now it should all be working, but we're going to look at it and break it down and take a good look at it. So let's keep it simple here as far as our numbers. So I'm going to use 100 here. All right, so that'll be our subtotal. Calculate. Okay, we've got one invoice, $75. That would be the average. All right, let's come in here and put in 500. Now, before I hit enter, think about how they should change. This should be 500. This will stay 25. This will be $125. This will be $375. So that should be 450, and 225. Let's see if the math is right. And it looks like it is. Now, the program, part of the problem we have with this program, just so you know, is if I leave it blank and I click calculate again, it blows up. You have seen this before. All right, let's change this. They use the convert to decimal. Let's use something that they mentioned in this chapter, but I want to be able to show it to you now. All right, what do I mean? I'm going to come in here and I'm going to add in here another variable. It'll be a Boolean. Whoops. Why I did that, I don't know, but I'm going to make a Boolean in here that I'm going to call result. And I'm going to set it equal to, in fact, I'm not even going to set it, just going to say Boolean result. Now, where we did this, I'm not going to do a convert to decimal. I'm going to take that line and comment it out. And then I'm going to copy it and put it back. You might say, well, why are you doing that? Because I'm going to change it from convert to decimal to decimal dot try parse. What are we going to try to parse? This. If it works, where are we going to put the number? I'm going to have to make a couple changes here, but just bear with me. Okay. We want to put the result into subtotal. All right. Like I said, give me a second here. I'm going to have to fix this. So I'm just going to set this to 0M to begin with. All right. Now I'm going to say down here, I'm going to say result equals this. All right. So if this works, let's see. Oh, I need the word out in here. All right. Now, it's the first time you've seen this. So if it's like, oh my God, I don't know what the hell you're doing, bear with me for a second. All right. This is a Boolean, which means it can hold true or false. Since we did not give it a value when we started, it automatically has the value false. All right. What we're saying here is attempt to parse or attempt to convert what is in that text box where we just put the value in. Attempt to put it in. If you can put it in, if it's successful, put the result in subtotal and set result to true. If you cannot parse it because it's blank or it's non-numeric, then don't put anything into subtotal. It'll retain its value of 0 and you'll set result to false. Why did I do that? Because now I'm going to come in here and I'm going to say this. If not result, and that is a shortcut, I could have also said if result equal false. Means the same thing. So if that's what we did, I'm going to say message box dot show. All right, and I'm going to say in here input was blank or non-numeric. All right, and I'm going to give it a title. I'm going to say invalid input. All right, it's going to have a button in there that's just going to say okay, and actually it is an error, so I'm going to put that in there. All right, and then when I'm done, I want to make sure there was garbage in that txt thing, enter subtotal. So I want to clear out the garbage by saying it's equal to nothing, and I want to put the focus there. And finally, I want to get the heck out of there. There's nothing more for me to do. So I'm just going to type in return. Now that may have made very little sense to you. Let's run it though, and maybe it'll make a little more sense then. So save all. Now notice before when I put nothing in here and click calculate, I got an error and the program blew up. Now there's nothing in here and I get invalid input. Input was blank or non-numeric, and it clicks OK and it puts my cursor back there. If I put in junk, it does the same thing. All right, what I'm starting to show you here is what's referred to as data validation. Okay, now I can still, and I could check this too, I can still put a negative number in there. All right, and I'm not sure why that's giving me those amounts, but it is. Okay, but I could check that too in here. So let me clear this, let me exit. So now I'm just saying, if this returns something bad, okay, well, this if and else is what we're covering in the next chapter, but I'm going to say in here, else, if subtotal is less than or equal to 0, I'm going to put another one of these message boxes in, but it's going to have a different method. Input was negative input. So now watch what happens. If I put in here negative 456, negative input, it clears it and boom, nothing happened. I am starting to do strict data validation. If I put in 0, that's also bad. Okay, input, well, I could say negative or 0. I probably should change that. And again, if I put this in, I get the other error. All right, so now I'm really doing some data validation in here. I'm going to here put input was 0 or negative. And we'll put in here 0 or negative input. Oops, lost my double quotes. Okay, so now when I get down to this point, I have a number in there and it's a positive number. All right, so let's go back and just check this from the top. Then we'll take another break. All right, so we came in here, I made this variable. This is going to hold the result. Result holds the value of the decimal dot try parse. Since it's a Boolean, it holds true if the try parse worked. It holds false if the try parse did not work. All right. Now we have changed this. Okay. And subtotal is now equal to 0M. It's equal to nothing. Okay. This stuff is all the same as what's in the book. So our percentage is 25. Our discount amount is going to be whatever that subtotal was times this. And in fact, it's doing this all the time, even if we left this blank, this data blank. That's not a good thing. We could move this code up, or we could move this code down. For now, I'm just going to leave it where it is. It does work. All right. It's never putting those values in there, but it's always doing the math. Okay. So this again, attempt to convert value in txt, enter subtotal to a decimal. If successful, put value into subtotal, just like that. All right. Okay. So really to clean this up, all right, I should, these two lines right here, okay, I'm going to take them, let me copy them to the clipboard. But what I'm going to do is I'm going to convert these lines. I'm going to make this 0M, and I'm going to make this 0M. All right. I only want to do that if all of this worked. So I'm going to put that code down here, but I've already declared the variables, so I can do this. What I'm doing is refactoring my code. I'm cleaning it up so it looks better, for lack of better words, than it did before. Now it's telling me right here with all these 0Ms, that's their default value. So I can get rid of that. All right. I do need my percentage. Sometimes you will need to give this an initial value. Sometimes you won't. How do I know if it needs an initial value? If I get a green squiggly underneath it, I'd get an error. I'm sorry, I'd get a warning, and it would say that that must have an initial value. All right. Okay. So there's my variables. I don't need this one anymore. So I'm going to change my comment here to declare, boy, oh boy, declare and initialize remaining program variables. All right. So we're doing that here. Attempt to convert value in the text box to a decimal is, if successful, put it into subtotal. All right. If not successful, print out a message box. Clear out text box, set focus to text box. All right, that's if that didn't work. If negative, if 0 or negative subtotal, again, print out a message box, clear out the text box, and set the focus. With a positive subtotal, all right, calculate all remaining values and put into associated text boxes. All right, so this is doing the calculation, and that's putting them into their values. All right, here Let's see. Add 1 to total number of invoices. Add current invoice total to running invoice total. And update average invoice total. All right. And then finally, put values into associated text boxes. Now, the only thing that I don't have that the author had was in their clear, they cleared everything. So in other words, they even cleared these 3 things. I don't think that's a right way to do it. Sometimes when I do that, I might have added another button and call them like clear and clear all or something like that, where I'd clear these. I'm just not doing that right now. So that's really, so the way that mine is different from the one that was in the book is that way. All right, what I just showed you. All right. And also the fact that I use the tri-parse because it's cleaner. That allowed me, even though I jumped ahead to the next chapter, that allowed me to go into there and use an if else with that tri-parse to make sure that what got put in there was, the first check was to make sure that it was numeric, not that it was empty or non-numeric. And the second one checked that it was positive. All right. So I'm going to give you a break in literally about a minute or two. But what I'm going to do next, let me save this. And I'm going to leave that open for now, but I'm going to bring up my payroll. And the first thing that we're going to do after the break then, close that down. I'm again, like I did before, I'm going to go and grab all of this. Where are you? There you are. All right. And after we grab this, I'm going to go in and make a copy of it just like I did before. All right. But we're going to add in here, we'll just make a total gross pay and total number of employees and average gross pay. The same way they did it. Why? Because repetition is a good thing. All right. I've got 1029. Let's come back, please, at 1040. I'm going to update this. After I do that, we're going to jump right into chapter 5. I will see you at 1040. Be right back. All right, it is 10:40, so I'm going to start back up. And the first thing I'm going to do is to come in, and this was called Payroll GUI 01. So I'm going to go to my solution. I'm going to add a new project. It will, as always, be a Windows Forms, C#.NET Framework. And again, this will be called payroll GUI 02. There it is. I'm going to immediately stretch it out a little bit. And I'm going to come back just like I did previously. I'm going to come back and Control A, Control C. And then I'm going to paste those in here. Okay, so I've got that. Let me unlock these, put it up there. That's about right, I think. And I'm going to have, just like we did before, this will have to be wider. Okay. Well, let's make these more narrow. What's that? Well, like that. Whoopsie. And then make these more narrow too. That looks about right. That's not too bad. All right, we're going to make some changes to this in just a moment. But as always, because I like to do this, I know I'm a little squirrely this way, but all right. So we've got that. I think these are all set. LBL first name, LBL last name, LBL hours worked, LBL hourly rate, and gross pay. That's good. T first name, TXT last name, TXT hours worked, TXT hourly rate, TXT gross pay, BTN calculate, BTN clear, BTN exit. Those are all done. So this will be right there. That will be LBL total number gross pays. Heck, let's just call it total gross pays. All right, and this will be TXT total gross pays. All right, and this will be LBL total gross pay AMT for amount. Okay, which will make this TXT total gross pay amount. And finally, this will be average gross pay amount. All right, I believe everything has been done. Let me rename the form. It'll be FRM. I'm just going to call it payroll GUI 02. And yes, I want to change this. Okay, and I will change my text for the form as well. gross pay, GUI number 2, just something like that. Okay. Now, just to get the preliminaries as always out of the way, accept button, let's set. Cancel button, let's set. Start position, let's set. And let's do the tab order. All right, so that'll be 0, 1, 2, 3, 4, 5, 6, 7. These are going to be read only in a minute. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. View tab order. Let's make these 3 again read only. All right, let's quickly run this. It's not going to work, but I just want to see what it looks like. Of course, you have to tell it which one to run, but all right. Looks like it's working to me. Okay. And I'm really going to go a little nuts here. There's a reason for my doing this, but I want to make sure this isn't empty. I want to make sure this isn't empty. I'm going to expect that excuse me, I'm going to expect that a person can't work more than 84 hours a week. I mean, that's 12 hours a day, 7 days a week. I'm also going to expect that a person makes a maximum of $99.99 an hour. So I'm going to set some constants up is what I'm telling you. So when we come in here, let's set up the constants first. So I'm going to declare and initialize program constants. So I'm going to have a const decimal, and I'm going to call this min hours worked, and I'll set that equal to 0M. You know, you were sick that week, you were on vacation, whatever. And I'm going to have a max hours worked. And again, that'll be 84M. And I'm going to have a min hourly rate. I'm going to set that to 0 as well. Maybe you're a volunteer employee or whatever. And a decimal max hourly rate. And I'm going to set that equal to 99.99M. These are all, and I think you realize this, these are all arbitrary. I could have set these to anything I wanted, but those are just the values that I used. All right. Now, so you don't have to watch me kind of, for lack of better words, just foible around in here. I'm going to come back to here. This is the old one. And I'm going to come back and I'm going to add the code that I had in here previously. All right, so we will do this. We will do this for the clear and for the exit buttons only. There's my exit button code. And there is my clear button code. Let's make sure these work. That works. And that works. Okay, now let's come in and start to write our calculate. Now this is going to be by far, this is going to be the most complex thing we've done all semester. What do I mean? We're going to make a check in here and a check in here and a check in here and a check in here. And we're only going to allow this to be set and these to be set if this isn't empty, this isn't empty, this is between 0 and 84, and this is between 0 and 99.99. Now, in the future, I think it's when we get to chapter 7, so that'd be next week, we're going to write individual routines for these, but we haven't gotten there yet, so I'm not going to do that. All right. But I am going to make that Boolean that we had before, all right, with a result. And I'm not going to give it a value. But the first few checks, a couple are going to be easy. So if txt first name dot text, all right, I'm going to say dot trim, which is going to remove any spaces I put in there. If that's equal to nothing, what do I want to do? Well, I want to do a message box dot show, and it'll just say something like first name cannot be empty. And then for the title, I'll put empty first name. All right. And it'll have an OK button and it'll say error. Now, I don't have to clear that out because it's empty, but I can give it the focus. So I'm going to say txt first name dot focus. And I'm going to return. There's no sense in me going on. All right. So that's what I'm going to do. All right. Now let me check. Let me test this and see if it works. There's nothing in the first name. Empty first name cannot be empty, and there it is. Okay. All right. So far, so good. The good news is the one for last name is identical, except I got to change first name to last name. So I'm going to copy this, paste it in, and I'm going to change this from first name to last name. And now I'm going to check this one. Let's do the first, even though it shouldn't break. Empty first name, empty last name. Okay, those both work. Good. There's a start. Now we've got to make similar checks. Okay, but we have to check for our hours worked and our hourly rate. Now I'm going to grab this, but I'm going to have to change. Whoops. Actually, I won't even grab it. So here I'm going to validate first name is not empty. And then I went in and I did a validate that last name is not empty. All right. So now I want to validate that hours worked is not empty and within range. Now, I think I can write it. We're going to find out right now. All right. But I'm going to say in here result equal, just like we did in the last program, decimal dot try parse. What do we want to parse? TXT hours worked dot text. If it works, where do we want to output it to? Did we make a field for that? No, we didn't. So let's make it right now. Decimal hours worked. Oops. Worked. And we'll make another decimal for hourly rate. And we're going to need another decimal eventually for gross pay. All right. So this will go into hours worked. All right. Now, if it didn't work, so if not result, remember that's a shortcut for saying if result equal false, we're going to do another message box, a different one. So this program is going to be littered with message boxes. and we'll say hourly rate. Oh, which one did we do first? Did we do hours worked? So I should change that to hours worked. All right, so it's hours worked, and that should say hours worked. So we'll just say here, invalid hours worked. How about changing that? I'm going to say hours worked must be between 0 and 84. And here we'll say invalid hours worked. All right, now there could be something in here. So we are, before we say our txt hours worked dot focus, before we say that, we're going to say txt hours worked dot text equal nothing. All right, now we should be covered if we put something non-numeric in there. Let's check. Put some garbage in there and garbage in there. Invalid hours worked. Hours worked must be between 0 and 84. Good. All right, but right now, if we do put something in here, and I put in here a big number, I'm not getting an error, which I should get. So I'm going to change this or add to this, else if the hours worked. So now we do have a value into hours worked. There is a value in there. So else if hours worked if it's less than the minimum hours worked, all right, or put another paren in here. It's greater than the maximum hours worked, well, then we've got an out of range error. So here we were validating that it's not empty. All right, validating that hours worked is not empty. Here we're validating that hours worked is within range. In other words, that it's greater than or equal to 0 and it's less than or equal to 84. All right. If it's not, another message box. And again, then we can say hours worked here. This is not invalid. This is out of range hours worked. Out of range hours worked. And this one is invalid out. I like to make my titles all caps. It's just a thing I do. All right. Now we want to clear it out and we want to set the focus. So that should also handle that. So you just saw, you just saw when I ran this and I put garbage in here and garbage in here. Now, if I put in a big number, out of range hours worked must be between 0 and 84. Boom. So now that worked. All right. Now the good news is, and I normally wouldn't do it like this, but I don't want you to have to sit and watch me type. All right. So I'm going to grab everything that I just did, all of this for hours worked, all of it. I'm going to copy it to the clipboard. I'm going to come down here. I'm going to paste it in, and I'm going to change these hours worked that were in here to hourly rate. All right, almost done. Now, hopefully I didn't forget to copy something, but we'll find out in the end anyway. So file, save all. So now if I put something in there, I put a 40 in here. All right, invalid hourly rate must be 0 to 99. If I do it again and put in too big a number, out of range hourly rate, okay. So if I do come in here and put in 40 as an example, okay, no errors. So now I can put in my gross pay. So if I get down to this point right here, all inputted fields were valid. Calculate and display gross pay. So gross pay is equal to hours worked times hourly rate, and txt gross pay dot text equals gross pay to string, and we will format it currency. And I'm going to take something very simple. So I'll say it's me, 10 hours, $10 an hour. Should give me 100 if it works. All right, so far so good. Now I have to account for this. I want to add 1 to my total gross pays. I want to add 100 to my total gross amount. And I want to divide the total gross pays by the total gross amount. Put that here. All right. So what I'm going to do, just so I don't forget it, let's see. I'm going to come back up to the top. And I want decimal total num gross pays, decimal total gross pay amount, and a decimal average gross pay amount. And I didn't put a semicolon on the end there. All right. So I'm going to just grab these so I don't screw them up and paste them in down there. I'm going to get an error, but it'll go away in a matter of seconds. All right. So total num gross pays plus plus. So in other words, I want to increment total number of gross pays calculated. Calculated. So total number gross pays plus plus says use of unassigned variable. So there's one time where it wants me to give this a value. So I have to say equals 0. All right. And now that has gone away. See that? All right. So now calculate and display total gross pay amount. Okay. And so what is that? I want to take the total gross pay amount and I want to add to that the gross pay. All right. And then I can immediately display it too. Now look, if you look here, again, it says unassigned variable. So it wants that one to be set. And I'm fairly certain it'll want that one to be set too. So I'll set that right now. All right. So we can say txt total gross pay amount dot text equal total gross pay amount dot to string. with currency. And I'm going to calculate and display the average gross pay amount. All right. And what is that? You already should know this. It is equal to the total gross pay amount divided by the total num gross pays. All right. And then finally, TXT average gross pay amount is equal to the average gross pay amount dot to string currency. All right, what doesn't it like? Cannot, oh, that's got to be dot text. All right, let's give it a spin. Again, I'm going to use simple examples. 10 and 10. Okay, I didn't print that out. Or I did it wrong. Okay. Let's see if at least this total gross pay is being added. Okay, it didn't work. Now, you may have already figured out why it didn't work. You may not have. All right, but I'm going to show you what I'm going to do. I'm going to take these variables, the total gross pay, the average gross pay, and I'm going to make them global. Like that. I want them to retain their value between program runs. They were not doing that. All right, so let's see if that does anything. Now, the problem was it wasn't printing everything out either. So let's double check that. All right, I didn't put that here. So TXT, TXT, where was it? TXT total gross pays dot text equals total number of gross pays dot to string, but that's a whole number, so I don't have to format it. That should put that number in there. That should fix this. Oh, I put gross pay in there. That should have been average, not total. All right, now let's take it for a spin and see if it works. So 10, 10, 10. There's 1, 100, 100. It's clear. All right, so this should be 400. This should be 2. This should be 500. And that should be 250. So it looks like it's working. Let's do one more. And this will be Sally Green. And we'll say she worked 40 hours, $40. So that should be 1,600, 3, 2,100, and 700. And it appears right now, at least, as though everything that's in there is working. So again, I am not trying to waste your time, but I think that there is really some benefit to doing something and then even doing it again or doing a similar problem. So that's what I'm doing here. All right. So with that said, and again, if you are watching this live, if anybody has questions, feel free to turn your mic on and stop me at any time. That's totally fine. All right. So let me do a save all here. And for now, at least I'm going to close that and I'm going to jump back into here. We did the enhanced one. Oh, it's stuck, so let me start it up again. So that was it for that chapter. So again, I'm going to jump into the next chapter. If you are interested, if you think I'm falling behind, I'm not getting this stuff, remember at the end of the chapter, you've got these exercises. You do not have to turn those in. You do not have to do those. But if you want to try those on your own, you've got the answers. All right. That's in the material that I gave you at the beginning of the semester. All right. You've got the exercise solutions in here, not the extra exercises, but those solutions. All right. Good news is this is not a real long chapter. The bad news is there's a lot of material in it. All right. So again, I'm going to go probably a good 20 or 25 minutes and then take another break. All right. We will do, we will go through this whole chapter. We will do their future value app. After we get done with the future value app, we will go in and we will make a copy of that payroll app we just did. And you may or may not have thought about this before, but we have not accounted for overtime in there. So if a person works more than 40 hours, we want to give them time and a half. All right, we could give them double time. We could do it any way we want, but we're going to do that. All right. In addition, I'm going to give you some program snippets, so to speak, where we'll talk about loops. All right. I don't know how long that'll take us to, if it'll be 1 o'clock, 1:30. I'm just going to keep going. Tomorrow's lecture, then what we will be able to do tomorrow is do this one more time. Is tomorrow we will go over chapter 6, which is how to code methods and event handlers. So I lied to you before, not on purpose, but we will take what we've been working on and break it up into different routines. All right. And then after we get done with that, we will look at both the homework and the labs. I'm not going to give you any help on the written tests. I'm going to ask you to do your own written tests for chapters 4, 5, and 6. The way I grade these is if you made an attempt, and I don't mean you put down C for every answer, but if you make an attempt and you got most of them right, then at a minimum you get 7.5. All right, if there's 25 questions and you got a couple wrong, I'll typically, give you still a 10. If you got 4 or 5 or 6 wrong, I'll give you a 9. If you got, closer to half wrong, I'll give you an 8. That type of an idea. That's how I grade those. And yes, I do look at them. All right. So we will do that. We will also, you will have to do those again on your own, but I'm going to look at these tomorrow, between today and tomorrow. We'll maybe do this one or this one or that 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 one. I don't know which ones. I'm going to look at them between today and tomorrow. Okay. And for the first time, we'll look at this projects thing. And there is a English to Pig Latin, which I hate those kind of programs. And there is a maintain student scores. Again, I don't know which one of those we'll do. We'll do one of those two. All right. And so tomorrow we should have plenty of time to both go over chapter 6 and also do some of the homework and lab problems. Then on Wednesday, I will give you another pretest. All right. I will again give you a good hour and a half to work on it. Then I will do the pretest from scratch. And Thursday will be your second hands-on test. All right, there is no class a week from today. It's the Memorial Day holiday. So when you come back Tuesday, we'll do chapter 7. Wednesday, we'll do chapter 8. Thursday, we'll do a pretest, but you won't have your third test until the following week. All right, that's just the way that it works out. Okay, so with all that said, let's jump into chapter 6 here. Sorry, chapter 5, how to code control structures. Broken up into 4 sections: Boolean expressions, conditional statements and expressions, loops, and they're going to do this future value app. All right. There are several types of control structures. We're going to talk about many of them in this chapter. I'm even going to discuss one that is not shown in your book. I guess it is shown. All right. But when we get into this loop section, we'll talk about while loops, do while loops, for loops. We'll also get into the break and continue statement. And when we talk about conditional statements, we'll do an if and if else and if else, if else, if else, a switch, and a few other things that are in there. All right. Again, I'll go till, let's say we'll go to 11:45, and then we'll take a break. All right. After that. So the first thing that's discussed in here is how to code Boolean expressions. You already know what a Boolean variable is. A Boolean variable is a variable that contains true or false. What that means is a Boolean expression is an expression that must come back to either being true or to being false. Now, you've already looked at these, whether you realize it or not. When we looked at the examples, when I just did in there in that payroll program, where we had if statements, etc. So you looked at some of that stuff already. But a Boolean expression must be true or false. The computer does not recognize a gray area. All right. Yeah, and it's kind of true, but no, it's true or it's false. Now, when you start to work with this, you start working with relational operators and logical operators. There are 6 relational operators. They are shown right here. The equality operator is 2 equal signs. If you use a single equal sign where you mean to use the double, you'll probably get an error, and vice versa, you'll get an error. This is checking for equality. So for this example, this is checking to see if first name indeed is equal to Frank. All right. Inequality is an exclamation point followed by an equals sign. Sometimes it's called bat equals because the exclamation point sort of looks like a baseball bat, or it's called bang equals, and that has to do with Linux or Unix terminology. That's inequality. Then there is greater than, less than, greater than or equal to, and less than or equal to. I'm going to take for granted that somewhere in your mathematical history in the past, you've gone over what those mean. All right, might have been 8th grade or whatever, but you do understand. And if you don't, take a look at the several examples that are shown here towards the bottom of page 139. And as the author says, you can use relational operators to create a Boolean expression that compares 2 things. All right, and it returns a Boolean value. So again, it returns a value of true or false. As it says for equality, it's 2 equal signs. Notice what it says. If you use a single equal sign, the program will interpret that as being an assignment statement rather than an equality check, and the program won't compile. When comparing strings, you can only use equal, equal, or exclamation point equal. In other words, you can't check to see if one string is greater than the other. Not with what you've learned so far. I'm not saying you can't do it, but you can't do it with what we've learned in here so far. If you compare 2 numeric operators with different types, so if you compare an int with a decimal, C# will implicitly cast so that you're comparing apples with apples. Remember, implicit means the computer did it. Explicit means you're doing it. So those were the 6 relational operators, and there are also 3 logical operators. Now you say, no, there's 6. Let me explain what I mean by that. All right. If I want to check for 2 things and I want them both to be true. So in this example, if I want both the subtotal to be greater than or equal to 250, and I want the subtotal to be less than 500. So in other words, the range for the subtotal is $250.00 to $499.99. If I want both sides of these to be true, I use 2 ampersands. All right, that's an and statement. They must both be true. Not only that, C#, like many programming languages, uses what's called a short circuit operator. So remember, this is an and, meaning these must both be true. Let's suppose that subtotal was 0. Since subtotal is 0, it's not greater than or equal to 250. Since this is false, it doesn't even make this check. It only makes a single check. Now, or is the opposite. With an or, you use 2 pipe signs. That's right up above your enter key, shift, and then hit right up above your enter key. All right. And only one has to be true. So in this example here with subtotal, if this said subtotal greater than or equal to 250 or subtotal less than 500, which wouldn't make much sense because that would cover everything. But if it was an or, if it found out that this is true, it doesn't check the other one. So with an and, if the first one is false, the second one is not checked. With an or, if the first one is true, the second one is not checked. Those are both known as short circuit evaluations. If you wanted to check both of them regardless. So, I don't care. I want you to check this side and this side. Then you use a single ampersand. If I want to do an or and I wanted to check both sides, then I use a single pipe sign. Typically, using the single one is not done often. Finally, the exclamation point is what's called, for lack of better words, it's a negator. All right. It takes something that's true and it negates it, making it false. It takes something that's false and negates it. In other words, it makes it true. Now, you can have very complex expressions that have ands, that have ors, and that have nots in the same expression. All right. There's an example right here. There is an and an or and an and. If you have all 3 of them, nots and ands and ors, you do the nots first. The nots are the most restrictive. You do the ors last. They're the least restrictive. And you do the ands rather, after any nots. If you don't want to do it in that order, you can circumvent the regular order of not, then, and, then, or by using parentheses. And that's what they say in here. All right. Okay. So how to code conditional statements and expressions. We're going to start with how to code an if-else statement. And what I'm going to do is I'm going to break away from this, and I'm not going to start a program because the stuff I'm going to put in here is going to be pretty flippin' simple. All right, I'm going to get rid of this, and I'm going to get rid of all that. And I'm going to do this. I'm going to say int legal age equal 21. And I don't care if it's 21 or 18. It doesn't matter. All right. And then I'm going to put in here, let's see, int my age. It's not, of course, but I'm going to say 18. All right. Then I'm going to say here, if my age fact, let's make this a constant. Const int legal age equal 21. So if my age is greater than or equal to the legal age, then I'm just going to do, I'll do a message box dot show, and I'll say something like you can enter. And then we'll put a title in there that says legal. And I'll put in here message box buttons dot okay and message box icon dot information. All right. I think you'd agree when you look at this that my age is not greater than or equal to the legal age. So what's going to happen? Absolutely nothing. It's going to skip the body of the if. The body is what comes between the curly braces. So it's going to skip this. And since I didn't tell it to do anything otherwise, all right, since I didn't tell it to do anything otherwise, there's nothing to do. Now, what if I do want to do something otherwise? Then I can come in here and I can say else. And I'll say in here, else you cannot enter. Illegal. Whoops. All right. So now what's going to happen is it is going to check. And since this is not true, either this has to run or this has to run. So when you do an if else, either the body of the if must run if the statement is true, or the body of the else must run if the if statement is false. So since my age is 18, and since 18 is not greater than or equal to the legal age of 21, what you see in gray will run. All right. Now, what if I'll leave that one here, but I'm going to put another one in here. And I may have even shown you this already. I don't remember. We may have gone over this, but I'm going to come in here and do this. Let's see. I'm going to say rand equals new random. And then I'm going to say int, let's see, number equal rand dot next. And I wanted to give it a number between 1 and let's say 500. So I'm going to put 501 in here. All right, so this will give me a random number between 1 and 500. All right, now I'm going to say if number is equal to 0, we'll do one of these message boxes. And we're going to say in here 0, oopsie, 0, not odd or even. And I'm just going to put in here 0. All right. Otherwise, so else, in fact, we're going to do that. We're going to say if it's 0, do this and just return. All right. So now I'm going to come in here and I'm going to say else. So if I get down to here, all I know is that the number All right. I know that the number is not 0. I know that for sure. Otherwise, if the number modulo 2 equals 0, well, then I know it's an even number. Technically, I don't even need this return statement in here or in here. All right, so we're going to say in here, even number. We'll make that even. And then finally, this will just be an else, but I could make the check if I wanted to, set if it equals 1, but I don't want to do an else if, I just want to do an else, so you see that. So this will say odd number, odd. Now, it worked out nicely because you get to see everything in here. So if this is true, if it gave me the number 0, and it won't right now because I put a 1 in there, so let's make that a 0. So that'll give us a random number between 0 and 500. If it gives us a 0, we say 0 is not even and 0 is not odd, but if that's true, we skip all of this. If it gave us a number, let's say 312, well, 312 is not equal to 0, so we skip this. Then we take 312, we divide it by 2, and is there any remainder? There's not, because it's 156 with 0 remainder. So we do this. We say even number, and we skip this. We run it again, and we get 567. Well, 567 is not 0, so we skip this. 567 divided by 2 does not give us a remainder of 0, so we skip this. So we do this. That is an if, else, if, else. You can have as many else ifs after an if that as you need to have. So I could have literally had an unlimited number of these. They have to come after an if. Also, it is not mandatory that you put a final else in there. That's typically used as a catch-all case for things that we didn't find earlier. All right, so let's take a look at what the book said about this. Syntax. Now, just so you know, if there's just a single line after the if, you don't need the curly braces. If there are multiple lines after the if, you do need curly braces. With that said, I always myself use and recommend that you put in the curly braces, whether it's one statement or not. All right. If you don't, I won't take off. All right. But if there's multiple statements and you don't put in curly braces, it'll be wrong. All right. So there is an if with many else ifs with an else on the end. Here's what you have there called nested ifs. What does that mean? If the customer type is an R, then you come in and do this in there. If it's not an R, you skip this inner if statement. So when you've got a nested if like this, if the first if is true, you do the second if. If the first if is false, you skip the nested if and go down to the else. All right, and I'm trying to be as whatever here is possible to make sure you understand this. All right. Now you may or may not remember. You may or may not remember. Let's see, where is that? Oh my goodness. Well, it'll take too long to find it. But for what we're talking about next with this switch statement, if you remember last week, I went over the example in the book, this example right here. This, that said, if you got greater than or equal to 88, you had an A. Otherwise, if you were between 80 and 87, you got a B. Otherwise, and we went through this last time. So that was an if statement, and that if statement had multiple else ifs with an else on the bottom. All right. Now, the next thing that's discussed in here is the switch. So to try to introduce that to you, I'm going to grab some code in here. All right, I'll just grab, I don't know how much I'll need, but we'll find out right now. Let's see. I'm just going to grab that and then come down here. All right, and I'm going to do this. I'm going to say string size equal S. Okay, now I'm going to come in here and write this. If size equal S, we're going to do a message box that says you are size small. All right, and this will say small. Okay, and we're going to have 4 sizes in here. I know there could be more than that. I get it. But to try to keep it simple, if it's an S, all right, else, if the size is an M, I'm going to say you are a medium. All right, else, if it's an L, all right, you're going to say that your size large. All right, else we're going to say if it's an XL, you are size extra large. And then finally, we'll add one more else. That should be an else if. Else, and we're just going to say here, unknown size. All right. So let me make this smaller so we see if we can see all of it, or just about all of it. I know that's pretty small. I get it. But this is everything. So if your size is an S, you'll get a message box saying that you're a small. Otherwise, if your size is an M, you're going to get an error or a message rather that says your size is a medium. Otherwise, if your size is an L, you're going to get a message box that says your size is a large. Otherwise, if your size is an XL, you'll get a message box saying your size is an extra large. Otherwise, it just says your size is unknown. And this will work just fine. Not a problem. But we're going to try to make it better. So I'm going to grab everything that we just put in. I'm going to open up some blank area here, and I'm going to paste it back in. And then you might say, why the heck are you doing that? Just give me a second. So I'm going to come in here and say, switch size. Case S, oops, break. I'm just going to write everything first, and then I'm going to copy the stuff in there. So small, medium, large, extra large, and this says default. Okay. All right. Now what you'll see is this has been rewritten, but rather than being written using an if statement or a series of if statements, small, medium, that should be large. It's been rewritten using what's called a switch statement. All right. What we switch on is what we want to check. So we want to check if size is an S or an M or an XL. All right. Now, what if the person comes in here and acts and puts in an S, but accidentally puts in a lowercase s? That won't match. That won't match. That won't match. That won't match. So it's going to say your size is unknown. If I want this to handle both upper and lowercase, I can come in here and say case S like that, and then copy these down. And that would be a little m, and that would be a little l. It doesn't matter which one I put first, does not matter. And this would be a lowercase xl, etc. All right. And you'll notice with each of these, you've got a break statement. We're going to talk about breaks after our next break. No pun intended. If the size was an S like mine is here, it does this, it hits the brake and it gets the heck out. If you leave the brake off, so if I'd have left this off and this off and this off and this off, it would have done all of them. It would have done what's called a fall through. It would have said you are a size small, you are a size medium, you are a size large, you are a size extra large, your size is unknown. All right. So this is the example that they used. And what they're saying is, what type of customer are you? If you're a R, which I would imagine is regular customer, all right. Now, maybe that's some kind of a special customer, must be royalty. I don't know. You get 10% off. If you're a C, maybe you're a champion, you get 20% off. Everybody else gets no discount. So as they say here, a switch statement begins by evaluating each match. After evaluating it, it transfers control to the appropriate case. The brake exits the switch. If you don't have any brakes, it'll fall through to whatever it finds one. Now, I'm going to take a break. Again, no pun intended, but we're going to talk about they have upgraded the switch statement. All right. So it is 11:45. Let's come back, please, at 11:55. We will, at that time, finish this chapter. It's not a super long chapter. And after we finish the chapter, we will jump right into, there's a future value program at the end of the chapter. We'll do that. See you at 11:55. All right, I'm going to continue on, and I'm on page 146, how to code switch expressions. What I just showed you was a switch statement, but in the last couple of years, the switch statement has been updated, upgraded, whatever you want to call it, so you can now run it like this. All right. And if you say, I don't get what that is, let's go back and rewrite the one that we did. So this is, I made a copy of the one that we'd already done. So I've got it up here. All right. So, and I don't use this one very often, but let's just see what they have there. Equals. All right. I'm going to say here, the size equal, again, I want to make sure I'm doing it right. Size switch. All right. And then in the curly braces, we now write this. So we write, instead of writing it like this, we now start writing it like this. Now you might say, does that really buy you anything? I guess it kind of depends on your point of view. All right, it's going to be a little less typing, but it's also a little bit more confusing to look at. All right. So let me go back and switch and change this, not switch this. Let me go back and change this. I'm going to get rid of these just because there'll be less typing then, but I want to do this. What you'll notice is the word break is now gone. That semicolon is gone. And this will now say like M without that. And again, and I believe that that is now correct. Let me double check in here. To my knowledge, it is now correct. This is not a switch statement like we looked at before. It is a switch expression, and it uses something called a lambda. All right. I don't want to talk about lambdas now. We're going to have a chapter, I believe it's chapter 18. All right. Right before we get into databases, that we'll talk all about lambdas. And if you say, well, geez, then should I even use them? I'd say no. I'd write it this way. It's a little bit more to type, but it's much more straightforward. Also, before, if we didn't match, so if your size wasn't an S or an M or an L or an XL, we used what's called a default value. Now, if it doesn't match, we put an underscore in there. And that underscore is referred to as a discard value. All right. And you're going to see some of these as we go on. All right. So a switch expression, as it says,